G'day, I'm Yuki-san Dev, and in part 24 of the series Unity for the Absolute Beginner, we'll just be going through some tips and tricks and random stuff. Alrighty, so this video is just a collection of bits and pieces or tips and tricks, or whatever you'd like to call it, for the beginner in no particular order. Just some random things that might help out. They will be in chapters, so you can skip to any of them. We will cover Color and Color32, component fetching locally, reference transform rather than the Gameobject, find the Gameobject and keep it private rather than making it public for the inspector, exiting play mode in the editor with your own quit button, making a custom font to use in your game, grouping conditional statements, triggers versus collisions, pivot and center handle position, local and global and the tool handle rotation, calculations on variable fields in the inspector, copying component data while playing the game, adding a slider to a variable field, and adding a Gizmo icon to an empty object so that it can be seen in the scene. Now, I think this just might be the last instructional video in the beginner series. Not really quite sure where to cut the beginner series off and call it intermediate. If and when I do come across something that should be in this series, I will certainly add it in here. I'm sure there's more beginner stuff that I haven't covered. The beginner series is kind of scripting with the obvious Englishy stuff, with lots of words that make sense, like random range, transform.rotate, invoke repeating, etc., where you can understand the meaning just by reading the code. Intermediate is getting into more of, what my friend used to call cryptic gobbledygook, with a lot more math and freaky abbreviations, etc. Some of the ways that we've done things in the beginner series will be changed or streamlined for versatility and performance, and some, just to keep up with the times. In my lifetime of programming, I have come across many a developer using the most complex and difficult code to perform very simple tasks, just to be, as they like to say, pro. But for me, personally, if it works and it doesn't affect performance, then there is no wrong way to do it. That's my philosophy anyway. But of course, after this video, to end the series, I will do at least 1 or 2 games, which will probably be quite a few videos. I will try to make use of everything that we've covered in the series so far in these games, and of course add some new stuff. Then I think in the intermediate series we will revisit the game or games and make use of the new and improved code. So let's get on with the tips and tricks. Right, so first let's look at RGB Color and Color32. So the only reason I'm slotting this in here is because I smacked it in the video for coroutines. So I thought I'd better cover Color32 in here. So the parameter for Color and Color32 are the 3 color channels R, G, and B. Of course, that's red, green, and blue. The 4th parameter is for alpha, with 0 being transparent and 255 being opaque. The 4th parameter in Color is optional, but in Color32 it must be specified. The range in Color for RGB is between 0 and 1 rather than 0 and 255. That's not just in Unity either. It's pretty standard now in a lot of engines. Even Roblox has the 0 to 1 system. The range in Color32 is the old 0 to 255. So we are going to fade the color on a cube from black to red using a while loop. Let's look at the 3 ways to do it. The first one is using color. The loop will keep running until color index is greater than 1. The color syntax is simply using the color index, which works because it's within the range of 0 and 1. Then the amount of increment for color index each time is 1 divided by 255, which roughly equates to this horrible decimal number. Now the second one is still using color, but this time we are incrementing color index by 1 each time, and then in our color line we are dividing color index by 255. So it's kind of the opposite of the above method. And the last one is using Color32. Color32 uses the old school RGB range of 0 to 255. Cool for old school me, but there's a catch. If you use variables for parameters such as color index when we set, then it has to be converted to byte format. And we can't make the variable up here a byte because you can't perform arithmetic on bytes. So you would get errors. So it has to be done here. Only other catch is that the alpha channel must be set too. And as I mentioned earlier, 0 is transparent, 255 is opaque, and everything in between. Now, personally, out of these three methods, I wouldn't touch the first one with a barge pole. The second one is okay, and the third one is good if maybe you're wanting to match the RGB color exactly to something from an image. You can just type in the RGB without stuffing around dividing everything. Also, just to mention that the code in here for fading color is a little cumbersome, and normally you would use something like lerp, and that will be covered in the intermediate series. Alright, on to fetching an object component locally. So normally when you want to access an object's component, you would first declare a container to hold it. Then normally in the start method, you would assign the component to the object. Then the rest of the script can access it. Get component, just like anything else, has performance costs, so that's generally why you would only fetch it once and then store it in a variable container that can be accessed in the script multiple times. But if it's a component that in this particular script you only plan on using once, then you can just fetch it on the same line as the manipulation code, so no need for the variable and assignment. But again, if you plan on using a component more than once in a script, then do store it in a variable. So let's say you have a prefab cube, and when it's instantiated, you wanted it to be a random color. You don't use renderer anywhere else in the prefab script, so in start, you could just have this. But of course, if you wanted the cube to keep changing colors during its lifetime, like this, then this would be bad. Why? Because in each loop, the script is fetching the renderer again and again, over and over and over. Ouch. So in this case, declare it first in the normal way. Okay, and while we're on the subject of components, let's just go over referencing transform rather than Gameobject. So if you wanted to track the transform of an object, rather than make a reference to the Gameobject like this, and then you would have to type in Gameobject.transform, you could just reference the transform like this, and then there is no need for that extra bit of code. Okay, now find the Gameobject and keep it private rather than making it public for the inspector. So also throughout the series we have been declaring a public Gameobject like this, and then in the editor dragging the actual Gameobject into the declared field in the editor. But did you know that you can make the Gameobject private and then assign it in the same script by looking for it, like this? Now there is no need to drag it in the editor, and you can keep it private. And there's also more than one way to find it. You wouldn't want to be doing this all the time because of course there are performance costs, but I'm just letting you know that you can do it. Alrighty, on to the next one. Use your application quit button to exit the play mode in the editor. So let's say you have a button in your application similar to the one we made in game 1. The quit button calls a function to quit the app, and then the code would look something like this. So all we need to do is create a conditional compilation statement using hashtags with if conditions. So change the code to this. So this if statement will now be decided when the game is compiled. So if it's compiled on the editor for running, then the exit play mode will be used when you click the exit button. And when you compile the game to be run outside the editor, the application quit will be written rather than play mode. So now in the editor, when you're playing, you can click your button and play mode will stop, and in your compiled standalone game, it will quit the app. Conditional compilation statements are going to be useful when you start making games for different platforms and want different things to happen depending on those platforms. So take a look at Unity docs. I will leave a link in the description for you to go and have a look. Alrighty, make a custom font to use in your game. So you have a favorite font file you would like to put in your game? No worries. Just drag the font you have into your project. Then click Window, Text Mesh Pro, and select Font Asset Creator. Select the font you just dragged in from the source font file. And depending on the font, you might have to play with some settings, but it usually should be okay to accept the defaults. So click Generate Font Atlas. And it's going to let you know if there are any characters missing, but the font will still work. Click Save, accept the default location. You can basically move them later, and you're done. Now in your canvas item, you can access that font and use it. Easy. And don't forget, in your shader for the font, you also have lots of stuff to play with. Okay, group conditional statements. So to keep things tidy and save on writing the same code multiple times, try to group your conditional statements using or and. For example, this script here will destroy the enemy if it reaches certain boundaries. Rather than write this in 4 separate if statements, you could just group all those conditions in one statement using or, which is represented with the 2 pipes. So you would change it into this. Also, the and is represented with the 2 ampersands. Alright, now on to triggers versus collisions. So up until now in the beginner series, I think we've only dealt with triggers. So for starters, triggers and collisions can both set off events using onTriggerEnter and onCollisionEnter. The main difference between them is that the collision involves physics and requires at least one rigid body in the equation, and trigger does not. Now, there have been many of the same example made with a car, a wall, and a finish line. So yep, I'll make the same one. A car colliding with a wall is a true collision, whereas a car crossing a finish line would be a trigger. The car colliding with the wall could spark a collision game over event, and the car crossing the finish line trigger could spark a U1 event. Basically, if you want 2 objects to interact with each other and still be able to set off events, then use collisions. If you don't want them to interact physically, then use triggers. For example, if you have 2 different enemies coming down the screen at different speeds, the faster red enemy has every chance of banging into the slower blue enemy and creating undesired results like this. Then you would simply make one of them a trigger, so it physically ignores the other objects, and then, yep, it passes right through. Or imagine you have an enemy that shoots, and you want them both to have rigid bodies. Then this happens. Every time it shoots, it puts the enemy off course. No good. So you would make one of them a trigger, and boom. No effect. Now for a collider. Well, let's say you want a ball to bounce and you want to count the number of bounces. Well, trigger won't work because the ball will fall right through the ground. So you would disable isTrigger so that it can collide with the plane, and then use onCollisionEnter to count the bounces. And voila. So we will be using triggers and collisions in upcoming games to get more exposure to these two. Okay, the pivot and center, the tool handle position. Okay, now I failed to mention this tool in the editor video a while back, so I'll mention it here. It's this tool up here. Now it's all about rotation for this guy. There's 2 good uses for this little puppy. The first is you will sometimes find when you import models from external editors or the asset store that the pivot point isn't exactly at the center. So here I have a rectangle imported from Blender, but I moved its pivot point to one of the edges. So when I go to rotate it, I get this. Well, that's not what I want. So if I go up here and select center, Unity is now centering the tool right smack in the middle of this rectangle and ignoring its original pivot point. So now it will rotate as I expect it to. So if you import something and are getting unpredictable results when manipulating it in the editor, then this might be the first place to look. Now just to note that this is only in the editor. If you were to rotate this in script, it will still rotate on the original pivot point. You would have to make the model a centered child to a parent and then rotate the parent, or get creative with script and do some math with renderer bounds, etc. But that's probably better left for another video. Now the second good use for this is when you have child objects with a parent. So here I have 2 cubes, a parent and a child. If you click on the parent with pivot enabled, you can see the entire family of objects underneath will rotate on the parent's pivot. Then if you select center, then the family will pivot in the center of all the objects. Alrighty, local and global tool handle rotation. So this is another one I failed to mention in earlier videos. This is this little guy up here. So first of all, for some reason, a lot of people have issues with global versus local. I have seen a lot of videos on this, and some of them do make it awfully confusing, so I hope I'm not going to be another one. So any parent or standalone object in the world is going to use world or global coordinates, i.e. the coordinates in the Unity scene world. Well, yeah, that makes sense. Then local is simply the child object's position relative to the parent. So take these same two cubes. So the cube parent has the global position in the Unity scene of x at -1, y at 0, and z at 0. Then cube child has the local position of x0, y0, and z2. So it's its position relative to the parent. So watch what happens to the coordinates of the cube child if I drag it out from its parent. Unity changes its x value from 0 to -1 because now its position is global, and to keep it in the same position it was when it was under the parent, Unity had to change the coordinates. So now, back to the tool. Firstly, this tool is only ever going to be of any use when you're dealing with parent and child objects. This button is all about moving along the same axis as the parent. So I want to rotate this red cube and then slot it into the blue cube. Okay, so I've rotated it 45 degrees on X. Now click the Move tool. The arrows are not aligning with the blue cube, so it's a little more difficult to get it inside the blue cube as we would like to. No worries. Select the global option and see the pointers change. Now they are aligned with the blue cube's rotation. So now I can just drag my red cube in to create my shape. It might take you a minute or a day to get your head around this one, but it'll probably come in handy at some stage. Alrighty, calculations on variable fields in the inspector. So here's something kind of random, and it could be helpful to somebody. Never really done it myself, but you can actually perform calculations directly in the inspector on values. Like here, if I wanted my speed for some unknown reason to be 20 divided by 1.4, then you can just put that entire statement into the field and Unity will work it out and give you the figure. You can do things like this with standard operators pretty much anywhere with a number. Copying variable data while playing the game. So you remember how when you change variable data while the game is running, the game when stopped reverts back to the original. Well, you can copy it while it's running and paste it in afterwards. So if I run this and then change these variables, and then click up here and select Copy Component, then stop the game, and click the same three dots and select Paste Component Values, and boom, there they are. Useful when using a lot of variables to tweak things to get it just right, then you can just copy and paste. Adding a slider to a variable field. Now I know we've already used this in our scrolling texture video, but I thought I'd throw it in here because it is rather useful. So this speed variable here, I will add a slider to. I will just edit the script. And right before the variable, slap in range and the two values. And now save. And voila, we now have a slider we can use to alter the number. Okay, adding a Gizmo icon to an empty object so that it can be seen in the scene. So let's say for some particular reason you might like to see where an empty object is in the scene without having to click on it in the hierarchy to see it with the tool sliders. Well, you could just assign an icon to it up here. You could select one of these bars to give you the actual name in the scene, or you could select one of these little diamonds for something a little less intrusive, or you could even select your own image by clicking Other. And of course the image would have to be in your project to be able to use it. And you can also add these icons to any objects in the scene. So there you have it, just a few random bits and pieces. Now I think the next video might just be starting to create our second game. So I hope to see you in the next video.